Hey everyone, welcome to this beginner electronic soldering tutorial. I'm making this video to demonstrate good soldering technique and to break down the process into 5 easy steps. Stick with me, practice a bit, and you'll get good at it too. You'll need a soldering iron, something with which to clean your tip like a wet sponge or a brass sponge, some solder, and while optional, a pair of helping hands can really come in handy. One more note, solder is very hot. Its melting temperature is almost twice the temperature of boiling water. Hot metal looks the same as cold metal, so be really careful. Also, especially if you're a beginner, you should be wearing safety goggles. So let's jump right into it. For through-hole components in a circuit board, you'll want between 600 and 700 degrees Fahrenheit. That's 315 to 370 degrees Celsius. If you're soldering larger connections with more copper that's dissipating heat, then you may want a slightly higher temperature. With a temperature adjustable iron, you can see what works and adjust accordingly. Next, make your components stay in place without your help. This is where you can use your helping hands. If you're soldering a through-hole component in a circuit board, you can bend the leads of the component into a V-shape so that it stays in place flush against the board. For components without long leads, you can use a piece of tape to hold them in place. There are any number of ways to keep your components steady, so feel free to get creative. Next, clean the tip of your iron. Use a brass sponge or a wet sponge to remove any oxidation or excess solder from the tip. A dirty tip is covered in metal oxides that transfer heat badly and can result in poorly soldered joints. Always remove excess solder because you'll only make reliable connections using fresh solder that has rosin in the core. Rosin acts like a flux when soldering, which eats away at the oxide layers that form on the surfaces of metals. In fact, the smoke that you see when soldering is the flux burning away, not the solder itself vaporizing. Without flux in the solder to clean your surfaces, you'd have a very hard time getting the solder to wet. Now we're ready to apply solder. The whole principle is to heat up your joint evenly and melt solder onto the joint, not the tip of the iron. Apply the iron to one side of the components that you're trying to join, and feed solder from the other side. The amount of time it takes to heat the joint depends on its size, the temperature, and the power of the iron. Tiny connections can take a few seconds, but large connections dissipate more heat and will take longer. Remember to make as much contact as possible between the iron's tip and your part. Hold the flat edge of the iron's tip against the joint, not just the point of the iron. Sometimes it helps to tin your iron by putting a small amount of solder on the tip, to bridge the air gap between the iron's tip and your components to create better heat transfer. When you're done, remove first the solder and then the iron. The joint will need a few seconds to cool, so don't disturb it. Last, check whether you made a good connection. Did the solder wet to both surfaces? Is the joint smooth and shiny? Is there too much or too little solder? On a printed circuit board, the connection should make a volcano shape adhering smoothly to both the entire pad and the component lead. Finally, trim the leads of your components if you need to. So now that I've shown you some good examples, let me show you a bad example so you know what not to do. The first big no-no is putting a blob of solder onto your iron and trying to transfer it to your joint. This won't work because your flux burns away and you're not ensuring that your work pieces get hot enough for the solder to properly adhere. Secondly, don't grab your joint while it's hot. I didn't burn my finger here, but I easily could have. Third, your workpiece is sloppy if your components aren't properly aligned. This example is of course exaggerated, but beginners often don't ensure that parts are properly mounted flush against the board before they begin. So that's about it for this video. Leave me your questions and comments in the comment box below, and be sure to like and subscribe if you want to see more videos like this.
Okay, so here we are getting set up and ready to solder. I have the pick guard and the electronic harness flipped upside down on my guitar box. Now, here's what you're looking for. There are 3 wires that are not connected to anything coming off of the electronics harness. 2 black wires and a yellow wire. I want you to notice that the 2 black wires are both soldered to a puddle on the back of the case of one of the variable resistors in your circuit. The yellow wire is soldered strategically to the center terminal of that same variable resistor. That differentiates them. These 2 are what are known as ground wires, the 2 blacks, and this is an active conductor coming off of the probably the volume control right there. So that is what we're looking at. Now, 1 ground wire and the active yellow are going to go through a hole and into a pocket where the jack will be located. The jack is where you plug your guitar cord. The third wire is another black wire. That is a ground which will be soldered on the back to the claw, if you will, where the springs attach. We will be soldering a ground wire onto this. That'll be our bridge ground. This is called the trim claw. It's adjustable in and out for changing spring tension. So what I'm going to do now is take a quick look at how we're going to get this guy poked together. I'll take these guys off. So I'm going to take a black and a yellow, and I am going to poke them through a hole which is right back here. I can feel it with my finger. Might stick them through one at a time, but I'm going to put a... Here we go. Now you can see that's as much as I can pull out, and I'm already pulling my pick guard down. I've got one more wire, the black wire. There's a hole right down in here which goes to the back. I'm going to peek underneath and make sure I've got that wire coming out, the ground wire. There's the ground wire coming out the back. Now that I have these two wires out for the jack and I have this wire out for the ground, I am going to use my yellow frog tape, and I'm going to tape down the pick guard so that it does not slide around or pull out the wires that I've already pulled through the holes. I want them to stay where they are. You can see I have my electronics cover taped on. Wires for the jack are sticking out of the front. I am going to flip this guy over. I'm going to place my furniture glides strategically so that the knobs do not hit the desk. There we are. And there's my ground wire. First, I want to protect that finish, so I am going to put this over the body to help protect it. And then I am going to put one of my small 1/4-inch thick boards over the body, and then I am going to throw on my stainless steel plate. Then I am going to take the trim claw, which I've now buried right here. Now you'll notice in the trim claw there is a punch out. They basically punch the metal, it's stamped, and it makes a little divot in there where allegedly you can get the wire in there. However, my experience is that stamping never opens up far enough in order to get the wire underneath of it. Also, we want to keep the wire away from the springs. My preference is solder this from the bottom. So there we have a divot where they did the stamp out for that little claw that the wire does not fit in. So here's what I'm going to do. I'm going to put that there. I'm going to take an alcohol prep pad, and I am going to clean down inside of that divot, that stamped divot, with the alcohol pad, and I'm going to wipe the surface clean. So that, let that dry a little bit, and that is now clean of any oils or residue that might have been on there from manufacturing. I'm going to make sure that my iron is clean and tinned. I'm going to wipe it quickly on the sponge. Then I'm going to take some solder, and I'm going to touch solder against the tip of the iron to make an impending drip. An impending drip of solder on the end of the iron. I'm going to put the iron away for a moment. Next, I'm going to take a pencil point, and I'm not going to put a lot on, but I'm going to get a small bit of soldering flux, and I am going to paste it down into, lay it down into that divot on the back of the trim claw and spread it out over the surface a little bit. And now I am going to take the iron, I'm going to add another impending drip of solder, and I'm not going to hold the exact point of the tip. I'm going to hold the flat edge of that conical tip right down into that divot where the stamping machine stamped out the trim claw there in the middle. Now this is a large mass for a small 25 watt iron. So I want to heat that up well, and I'm going to poke some solder down into that hole as it gets warm enough. Now I'm pumping solder into that divot on the back, and I'm going to make a puddle of solder that extends beyond the divot and, hope my hand's not in the way too much, extends beyond the divot and overflows onto the surface. Done. So there is a nice puddle. I'm going to wipe the iron on the sponge, and I'm going to set the iron aside on its holder. Now, let that cool a little bit. That son of a gun is going to be hot. Now what I'm going to do is I'm going to get it close to my wire. My wire does not have enough insulation stripped off the end, and this is probably smaller than the tiny 20 gauge die that I have on this. Guess what? It is 20 gauge. Hot dog. And I'm going to trim off a little more of the insulation. The tip of that is already tinned, holding it together. Now, I am going to want to lay that right on top of that existing solder. So what I'm going to do is I'm going to take a little more flux, and I'm going to put a little more flux on top of that puddle. Just get a little of that on the puddle, and a little on the wire, just a little of it. Now, my iron is hot. I want to have something to hold with. So I'm going to hold this down with this guy right here. Just some kind of a tool to hold it down. Now, I'm going to take my iron, which is hot, and I'm just going to press again the edge of the tip against the wire and against the solder puddle there until the solder melts and the wire sinks in. I now have the guitar flipped over, and I'm ready to solder on the jack, which will go in like this. Now, there's two wires. Which wire goes where? Let's do a little history lesson. This is what's called a 1/4 inch phone plug. Some people call it a guitar cord plug or a guitar plug, but the real name is a phone plug. That comes from the telephone industry. This is exactly the kind of plug and jack that used to be used on the old switchboards years ago. Remember Lily Tomlin, 1 ringy dingy, 2 ringy dingies. And terminology here. There's a little black insulating line right there that separates that part of the plug connected to one wire from this part of the plug connected to the other wire. The standard names for these were tip and ring. And in the jack, I want you to notice that there is a spring clip that ends up grabbing the tip of the plug, and there's a little barrel down here which touches the ring of the plug. So when I plug this in, I have tip is grabbed by the spring clip, ring is grabbed by that little barrel that it goes through. That helps us determine what wire goes where. The wire that attaches to the barrel or the ring side is the black ground wire. The wire that goes to the tip side or the active wire side is the yellow wire. So if we examine this, you can see that that barrel, the ring side, the ground side is attached to that tab right there. Obviously then, the other one that goes under the insulating phenolic material is attached to the tip spring clip for this. So I'm going to pause here. I'm going to get set up to solder this, and we'll be right back. Okay, now we are ready to solder the output jack. I'm all set up. I have put drapery over my body. I want to protect the finish I've put on there. Put a piece of wood under there just to catch any drips. I have stripped back the two wires, some of the insulation, to make it just a little bit longer. I have hooked the wire through the terminals in the correct location. Notice that the black wire is on the ring or the ground side, and the yellow wire goes to the spring clip or the active side. I have bent them over and pinched them down with needle nose pliers so there's a little bit of a mechanical connection, and I have applied a small amount of flux to each one. Next step, I'm going to take my soldering iron and I'm going to take my solder. I'm going to make sure my iron is clean and shiny, which it looks like it is. I am going to put on a rather sizable impending drip of solder on the tip. And I am going to use the solder on the tip to make the connection. So I'm going to go to the first one. I'm going to touch and hold and count. 1001, 1002, 1003. Pull off gently. Make another impending drip. Go to the second terminal. Touch and hold. 1001, 1002, 1003. Lift off gently. Now I should have two very good solder connections. I'm going to clean my iron, unplug it, let that cool, and then I'll show you what's next. So that's it. My soldering is done. And before I screw down and install the pickguard electronic harness and the output jack, I am going to just tape down the output jack, and then I'm going to do an amp test.
Hi guys, Paul here at Radio Shop Pickups in South Wales, and thanks for joining me for part 5 of this series, Guitar Soldering 101. And in this episode I'm going to be looking at soldering to the jack. So I'm going to solder the white hot wire to the tip, and I'm going to solder this black ground wire to the ring. Okay, now the first thing I'm going to look at is actually tinning the wires, but I mean I've already tinned it a little bit. I'm using hookup wire, which is great because you can pull it back. Now these are tinned a little bit, but I'm just going to show you a little bit of my tinning procedure again. And a little tip for you here when soldering a jack like this, it's so much easier if you attach it to the thing that you're going to actually be attaching it to in the end, because it's less likely to move around then. Because if you try to just solder to a jack, a bare jack on a tabletop, it's going to roll around and it's not going to be a good patient really. So getting it stationary and attached to something like this is a good idea. I've also got a cloth down because, you know, we do have accidents, we do have dripping, and we don't want them to go on the paintwork of the guitar. Although it wouldn't be too disastrous here because it would go inside the cavity, but you could be working on something like, let's say, a 63 Strat, let's say. You don't want that to be happening. So I'm going to tin the wires here and just go through my tinning. But obviously, if you've seen part 1, then you'll see me going through tinning in some depth. And what I like to do with hookup wire, because later on I'm going to be pulling the hookup wire, or pushing it rather, to actually meet the solder joint, is just like to chop off a tiny bit. Because when you've got a bit of excess wire, sorry, a bit of excess cloth rather, it becomes easier to push it straight up to the joint. Always worth at the end as well, checking your cavities, because these little bits I trim off and things as they go, they can obviously gather in the guitar, and then you've got something rattling in your guitar and you're thinking, hang on, what's going on here? So I'm just going to tin the two places where I want to end up. And again, now this one, the solder here wants to go underneath, so I'm going to try and just add to the top and get it to fall. Oop. Now look at that, starting to drip. So if you've seen me in a previous video, I'm just going to change it so that I dip it that way a little bit, so that I use gravity to actually help it to go where I want it to go, rather than dripping down. Okay, and I'm inspecting that and that's looking good. I've got enough solder. And I've also got enough solder on the tips of the wires to help fill too. And just add that there. Now I might do the black one first. I'm probably going to need to bring my jack just a little bit closer. Again, this wire is great because rather like the plastic stuff, which tends to melt away as well when placed in close proximity to the soldering iron and the solder, this stuff doesn't, although it can fray obviously, and you can pull it back so it's well away from the action. Do your soldering and then you can push it up. So even though it seems a little bit archaic, this sort of hook up wire, it's really practical to use and really nice to use as well. And obviously it's the vintage stuff, so if you know, obviously a lot of our customers come to us and they're doing some sort of vintage style project rather, and I'm using fingers now to hold it in place and try and go in as quickly as I can. Try not to get in the way, but I probably am in the way a little bit. I'll hopefully be able to show you a little bit more depth on that one. I'm happy with that. Oh, actually it's protruding a little bit too much. I only want it to protrude really by about a millimetre. And now I can push that to meet the solder joint. Okay. And this one I'm going to do as well. I'm going to kink it a little bit because I need a bit of help here because I'm running out of wire really to come through. So I'm going to kink that. Now one of the things you can do is angle it down a little bit through the hole, because then, you know, if you think about it, these are going to be pulled a bit like that and you don't want them, we'll need to tighten that up, you don't want them later on to get to the point where they could possibly break. So helping it into the direction where it's going to end up is a good idea too. So I've got enough solder now. I'm just going to get a little bit on my tip, and I'm very, very close to the plastic of the card, so that's another thing to be aware of. Melt through that plastic card and it's not going to look very good, is it? So I'm close to my fingers too. And this is a bit of an example of some of the contortionism you've got to do really with soldering sometimes, and using spare fingers really to hold things down, and I'm happy with that. We've got a good shiny joint on both sides. I'm going to push the hook up wire, so it meets it there, and then I'm going to get it into place, screw it into place, and I'm going to move on to part 6. So hopefully I'll see you very soon. We're going to look at soldering to the trem claw. Thanks for watching, guys.
Okay, so I have got my soldered output jack taped down in the orientation it needs to be. And what I'm going to do next is do an amp test. I've got a small amplifier right here, guitar cord plugged into the amp. I'm going to turn the amp on. Test number 1 is referred to as a tap test. So if you take a ferromagnetic tool of any kind, tap, and you can hear that going. Now the volume control will work, but the tone control does not. Here's another interesting STEM topic you can discuss with your students. Here's an aluminum tuning fork. Watch this. I'm going to tap it. You can hardly hear anything. Here is a steel ferromagnetic tuning fork. You hear that? Big difference. Here's another cute little trick for testing your guitar. I have my phone set to YouTube. I got some cheap American Airlines earbuds that I got in the last flight I took. I'm going to hit play, playing a little Doobie Brothers here. I'm just going to take this earbud and I'm going to put it over one of the pole pieces. Hear that playing? Take it off, put it on. Now what I can do is, I can test the volume control, volume down, volume up. I can test the tone control. Turn the tone control. Here it go mellow. Here it go bright. So my electronics are working. What that means is I'm now safe to install my pick guard with the electronics, and I am safe to install my jack. Now this should be pretty straightforward. There are pilot holes pre-drilled into the body. There's already a video in the canvas somewhere in one of the modules on how to clean out all the finish material from your pilot holes, because it's going to fill up with varnish or whatever. So make sure you watch those videos on cleaning those out, and then go ahead and lube your screws and screw this guy down. Same thing here. Clean out the pilot holes in the body, lube the screws, and screw this guy down. You are done.